So my name is Bert-Jan, I work at Open Value. And it's my pleasure to introduce to you the former CTO of Triplingo, which you probably all know, or not.
Probably not.
President of the Atlanta Java User Group. I had the pleasure of joining the Nexus conference last year with a couple of friends in Atlanta. And Pratik was the host there, and we made us feel really welcome. Thank you.
Welcome.
He's also the VP of Developer Advocacy at Azul. Azul makes you run the best and fastest Java at the planet, so go check it out.
What he said. Now I can just skip all those slides. That's perfect.
Yeah, so now we can just enjoy cloud cost optimization for developers. Give it up for Pratik.
Thank you, everyone. Thank you for coming out, of course. So before we get started with this, is there anyone in here who's not a Java developer? Okay, so what are you guys building then?
Scala.
Scala, okay.
YAML.
With YAML. You're a YAML developer? I'm so sorry.
Yeah, just mostly Kubernetes and Kubernetes
Okay,
installations.
that's fine. What about you?
I'm not building at all. I'm a product architect.
Okay. So does Scala run on the JVM? Okay, I'm just joking. It does. So Scala is one of the languages I actually don't like on the VM, but we can talk about that over a beer later. Okay. And how many people are deploying into either public or private cloud? That should be everyone in the room, I would assume. That's why you're here, right? How many people do AWS or deploy into AWS? Okay. How about GCP? Oh, 2 people, 3, 4 people were doing GCP. That's a new one. And you're deploying Java apps onto GCP, is that right? Interesting. Okay, we can talk about that later too. But how about Azure? That should be everybody else in the room. Yeah, that's usually it. Anyone deploying anything onto something a little bit more esoteric aside from those 3? Private cloud?
Yeah.
Okay. Do you run any infrastructure tools to help you manage your private cloud, or is it all just sysadmins? Sweaty sysadmins in the basement doing all the stuff manually?
No, they have tools for it, and Kubernetes based.
Okay, so you're running OpenShift?
No, I think it's
Okay, I'm just curious.
different. No, I think it was a different.
Okay, anybody else running, like, aside from, I don't know, like Alibaba Cloud or something like that?
OpenShift, I thought you were mentioning OpenShift.
OpenShift, okay, got you. Okay. All right, so thanks for the intro, so I'm just going to skip this slide. You may have read one of these books. We do run this great conference in Atlanta called DevNexus. We're projecting about 2,000 people there. And there's a short Indian dude with a mustache called Venkat who always speaks there, for example. You may have heard of him. He's going to be there, and lots of other people. We have 14 concurrent tracks, and it's super cheap. And one thing I can guarantee is that it will be much warmer than it is here today in April in Atlanta. You'll be outside in shorts and a T-shirt. So come and join us for that, okay? All right, and Bert-Jan also mentioned our VMs that the company I work for make. So we have a lot of people use the Azul Zulu OpenJDK build. So basically, instead of using Temurin or Adopt or whatever they call it now, you can use our JDK because it's much better. I'm just kidding. It's exactly the same, but we get out security fixes and other things like that out into that much faster than the Temurin. What is it called now? I keep forgetting. They changed their name.
Yeah, it's Temurin.
Is it still Temurin?
Yeah.
Because they change their name every 2 years, so I'm having trouble keeping up. So, and I'm going to mention the second one a little bit, right? So this is not a product pitch, don't worry. I'm going to talk a little bit about Azul Platform Prime, which is our high-performance JDK, which works really well for cloud cost optimization. Okay, so we'll spend very small amount of time on that. Okay, for example, we've had one of our customers replace OpenJDK with Apache Kafka, and they saw a 30 to 40% improvement in throughput, which means either you can push more stuff through it, or you can get rid of 30% of your servers just by replacing OpenJDK for Kafka. Okay, but we'll talk about that a little bit more. All right, so does anyone know what this is from?
Silicon Valley.
Silicon Valley. Okay, good. You watch TV here apparently then. So when this came out, I was working at a startup called Triplingo, and I had to stop watching this because it was way too much like real life. I'm not joking, right? So never do a startup. It's a bad idea. But in reality, when I think about the cloud and where I was when I was at this startup, which was about when we started, it was about 12 years ago now. We were using a platform as a service called Heroku. So which some of you probably have used, right? And we're like, wow, this is great. We don't have to set up any infrastructure. We just say, here's some stuff and go run it, right? And scale and all that kind of stuff. So we'll talk a little bit about platform as a service in a minute as we start talking about different architectural considerations around thinking about cloud and deploying onto cloud and how do you manage cloud costs. Right? All right, so this is an interactive session. There'll be lots of questions, and I promise there's only 1 or 2 trick questions. The rest are straightforward questions. So what's the best way to reduce cloud costs? Anybody, come on.
Don't drop anything in the clouds.
That's a great answer, actually. Let's turn off the servers. Right? What are some other ways that you could reduce cloud cost?
Reduce traffic.
Reduce traffic. Basically have less users, but that's usually the opposite of what you want to do. So we'll skip that one. What's that?
Traffic within different parts or different systems, like, and depending on the cloud and the systems that traffic can cost extra. So
Are you talking about egress and ingress data fees?
yeah, and so depending on like cross regions and that sort of stuff. So
That's right. The multi-region data transfer fees can be quite high. That's true. Yep. Anybody else?
Functional tests, don't do them.
Don't do functional tests on the cloud, or don't do them at all.
Don't do them excessive.
Excessively, right? Because if you spin up something, maybe it's part of your.
Commit or go through the whole pipeline.
That's actually a really good point. Do you need to run a full CI and CD pipeline for every commit? Right? Is that a waste of resources? Because now you're paying for the cloud instead of just running on some servers that you have, somewhere in your company or under your desk, right? So those are all good answers. And of course, this is a trick question. It depends on your app, right? It really does. And we'll talk about how this depends on your app in a few minutes. The real answer, in my opinion, though, is that there's no one-size-fits-all solution for this. So in U.S. English, we have a term called silver bullet. There's no silver bullet for this, right? You can't just sprinkle some magic dust and boom, your cloud costs are lower now. And we'll talk about some of those nuances. And there's 6 key things that I look at when I'm working with a customer or doing research in this area in terms of reducing cloud costs. Okay, so this is what we'll cover real quick. We'll talk about the architecture of your app. We'll talk about the different deployment models, right? Everything down from PaaS or bare metal up to Kube. And we'll spend a little bit of time specifically on the Java part, right? How does the JVM play a role in how do you effectively manage your cloud costs, okay? And spend a little bit of time about how do you accommodate for headroom for variable load, because obviously nobody has load that looks like this. Load is always like this, or maybe it ramps up at 8 a.m. and then just spins down for the rest of the day. And probably the biggest problem, and I don't want to ruin that, is do you over provision or do you go for elastic compute? The answer to this question actually is much more complex than just do one or the other. Okay, so we'll get all to that in a second. But before we do that, let's talk about cloud pricing. Right? So here's a question for you: has the cost of compute, let's just focus on compute and memory, right? Forget about data storage and all that kind of stuff. Let's make this question really easy. Has the cost of compute and memory for cloud resources, whether it's AWS, Azure, GCP, whatever, has it gone up over time? Has it stayed the same? Or has it gone lower over time? What do you think?
Lower?
Okay.
Just say up.
Oh, you're saying up, okay. All right, so we have a few lowers here. What else? Up, okay, up. Okay, so everyone has heard of something called Moore's Law, right? Yeah. Moore's Law is that transistors in micro CPUs, whatever, double like every 2 years or 3 years or something like that. And that was true in terms of, actually may still be true, but Moore's Law has definitely slowed down. But if you think of the hardware that you're running on your desk, right, like your laptop or whatever, for many, many years, it was every 2 years you had to buy a new computer because that new computer was at least 30 to 50% faster than the old one. So Moore's Law is kind of in our rearview mirror now, right? It doesn't really apply to a lot of the things we do. Yes, we have these gigantic core CPUs, like the Xeon processors, or what are the AMD ones called that have like a massive number of cores in them? For the server. Epic. Have you guys heard of Epic? It's basically it's the server version of the Threadripper and the Ryzen CPUs, okay? So, has the cost of cloud actually gone down over time? And another anti-pattern is, will you ever use the cloud less for your applications, right? No, of course not, because you're always building new features or new apps or whatever. So unless you're shutting your company down, the cost of your cloud is, how much you spend on cloud is actually going to go up or stay the same, right? And we'll talk a little bit about the last one is, do you refactor your applications from monoliths into microservices? What kind of impact does that have on how much you spend on the cloud. Okay, but before we get to that, let's talk about this diagram a little bit. I'll send these slides out later if you like, but I found this nice slide about the cost of compute and memory for US East Q2, this is basically AWS, over time. Okay, now if you look at this chart, and this goes back to 2019, so let's say about 4 years, only the last 4 years, okay? But you can see that those people who said the cost of the cloud is the same were actually pretty much correct, right? And this doesn't make sense if you think about it, because for all the computer things, the cost should usually, or has historically, gone down over time, okay? So it's true for a consumer type of thing, like, well, maybe not MacBooks, that's an Apple thing, but you get the idea, right? Like if you buy a desktop PC today and you buy one 2 years from now, that PC will be much faster, well, not much faster, but will be at least 20% faster than it was. But somehow the cost of memory and compute in the cloud has not gone down over the last few years. Okay, so this is something to bear in mind when you're thinking about scoping out your project for the next 3 years or whatever. Is it going to
be related to energy pricing?
Could it be related to energy pricing? Well, maybe over here, but in America, where I'm from, energy is still cheap. The cost of energy in the U.S. has not gone down. And again, this is U.S. East 2, right, which is in the Washington, D.C. area. I think they have a gigantic nuclear reactor that powers that city, but I could be wrong, okay? Anyways, right, but that's actually a great point. Could be the cost of energy, but again, this is U.S. East. So, and there could be other factors as well, right? Because right about here, as most of you remember, is when we hit something called the pandemic, and that messed everything up. So, okay, but anyways, I just want to give you an idea of what this actually looks like. So to make the assumption that our cloud cost for the same stuff we run will go down over time may be an incorrect assumption. Okay, and we're going to talk about this a bit later. The Graviton and Epic-based VMs for doing compute, right? Does everyone know what Graviton is? Graviton are ARM-based server microprocessors. So it's an alternative to x86. And we'll talk specifically about why there's this inflection point and how much cheaper Graviton is in a few minutes, okay? All right, so now I don't want to spend a lot of time on all these different things. We were just talking at the table over here, and where's Bert-Jan? Is he still here, or has he gone home? Oh, there he is. He's still here. All right, so you were saying something earlier about the storage and network fees, right? So we don't want to dive too much into this because that's an entire hour presentation itself. And how do you manage storage in the cloud? You know, what do you do with egress and ingress? How do you go around all that stuff? So we're going to focus more on compute and memory and things which you as a developer have a little bit more control over, okay? And then, of course, the other things that affect cloud pricing factors are the different shared services that you're using, APIs, you know, what's your database look like? I actually really like serverless style databases up until a certain point. You reach an inflection point with serverless databases, or actually anything on the cloud, where if you use enough of it, you actually end up spending more than just doing it yourself. But we'll talk about DIY in a few minutes also. Okay, let's spend a few minutes talking about scaling real quick. I don't want to spend too much time into this because I don't want to cut into Paul's. Is Paul still here? I assume, right? I don't want to cut into your time too much. So I'm going to go over this a little bit quickly. If you have a question, let me know. Okay. So the first question here is, what's more efficient, a monolith or a distributed compute model or distributed application model?
It depends.
Oh, no, you can't. I'm only allowed to use that, not you.
Monolith, of course.
Yeah, monolith, of course. Okay. So this is actually true to some degree, right? But there's, again, there's a lot of nuance around this, right? And so the difference between doing a monolith and doing distributed computing, the core of it is vertical as opposed to horizontal scaling, right? Is everyone familiar with vertical versus horizontal scaling when you're deploying applications? Is there anyone who's not? Okay, good. If you're not, if everyone's familiar with it, then I'm just going to breeze over this real quick. So vertical scaling is you add CPU and memory to an existing server, more or less. Horizontal is you add more servers, right? So it's scaling up versus scaling across. So when you do vertical scaling, you add more CPU, you add more memory, you use a faster backplane that may have faster network, right? We've gone from gigabit to 10 gig networks, for example, to make things go faster on a single server. In terms of the backplane, we have DDR5 memory. We have processors that have, I don't know, what's someone said Threadripper CPUs. How many cores do those things have now? Like 128 cores or something ridiculous, right? Yeah. So anyways, that's vertical scaling, or having multiple CPUs multiple CPUs in the same server. Okay, so what's the cost of scaling the two? And I'm not going to draw this down, but when we think about horizontal scaling, we know that we pay a little bit of a penalty up until we reach a certain point, and then we basically get linear scale with horizontal scaling or distributed computing. That's why we do it, right? Because we know that we can just add servers instead of having to take our server, replace it with one that has a faster CPU or more cores or more memory. We just add servers. It's much easier to it's much easier to add a server to the side than to actually replace a server and have more memory and CPU and all that kind of stuff. And of course, with vertical scaling, one of the problems you hit is that once you've exhausted the number of CPUs or the memory or how much speed the backplane on that server can handle, you hit a point where things just get slower. The latency, i.e. the cost, gets worse. Okay. And similarly, you can add more CPUs, but again, because of the traffic inside of the server, the number of requests doesn't scale up linearly. It tends to like kind of, you have a long tail where it just kind of flattens. You get incremental gains in the number of requests. Okay, oops. Sorry, wrong slide. Why is this going the wrong way? Sorry about this. I don't know what I'm doing here. Okay. All right, so vertical scaling is linear to a point. Horizontal scaling is linear at scale. That's why we do it, okay? The other key thing is that horizontal scaling is also elastic, which means that you can scale up and scale down relatively easy. All right, so that leads us to a question on architecture in the app spectrum. And so when I think about what is it that we're doing in terms of how we think about our application, on the left we have monoliths. Everyone is familiar with that. Monoliths typically have vertical scaling and they're not elastic. They can be. We'll talk about modular monoliths in a minute. And then you have microservices and containers as a service in the middle of this. And at the far end of the spectrum, you have something that is extremely elastic and uses a huge amount of horizontal scaling, and that's functions as a service or cloud functions, right? So everyone's probably familiar with lambdas and cloud functions and stuff like that, okay? So this is the spectrum when I think about how to architect an application, or if I'm doing re-architecture of an application, what is it that I need to do? So an elastic horizontally scaled deployment theoretically has the ability to do cost control, right? So it's not as rigid and fixed as doing vertical scaling, right? So you have the ability to scale up and down, but I still don't like Kubernetes. Sorry for those people who have to use Kubernetes, but not a big fan and never have been. We can talk about that afterwards over a beer, so if you like, okay? Now, with the things that were on that diagram previously, we have, of course, platforms as a service, containers as a service, which is roughly, in my opinion, close to what Kubernetes does. And then we have cloud functions at the far end of the spectrum, right? So these are the architectural choices that you have as a developer or architect to build something, right? Which one of these would you pick for your application? Of course, the answer is it depends, okay? But if we change the way we think about this in terms of, well, instead of putting the design of our application and the user experience and all those other things that we have to think about as a developer at the forefront, what if we also include cloud costs as part of the initial discussion or thought process around how we should build an application, right? Because how many people do that today in this room? When you're starting a new project or you're refactoring an old project, how many people think, you know what, I should really think about how much this is going to cost to run and deploy? Does anybody in this room actually do that today?
From a hobby project.
Yeah, of course, for your hobby project, because that's your own money, right? So, right. And
I think about it, but often you don't get to see the cost, or you don't have such a say in it.
right, that's true. Sometimes you don't have a say in it. Sometimes it's just mandated that you must use AWS and you must use this kind of architecture, to, like whether it's a CaaS or Kubernetes or something, right? So that's completely true, right? But this is one of the things I think we have to shift as a developer, to have the ability to project 3 years out and say, how much is this going to cost to run 3 years from now? And if things are not so good at my company, how are we able to cost effective to run? Which is really interesting because I put this slide deck together about 3 or 4 weeks ago, and like literally 3 days ago, can you guys all read that? I know it's a little small, so let me zoom in here. Okay, so this was tweeted by somebody. Why does Google recommend modular monoliths instead of microservices? And again, this just came out, this was just tweeted 3 days ago. And so this guy's quoting from a research paper, ironically, recent paper by authors from Google, right, found that using a modular monolith is more cost effective and has lower latency than using the other deployment models that they looked at, right? So this is kind of shocking in some ways, right? Everyone's into this microservice type of mindset and everything. And now there's this research paper, oh, by the way, from a cloud provider that says, yeah, actually modular monoliths may be the best way to do things in terms of cost, right, and efficiency, okay? So there's right, so you can see the quote here at the bottom. This is, I took this from the paper. Again, I can send this out if you want to read this. It's actually a fascinating read. I don't know if I agree with all of their assumptions, but I agree with their overall conclusion that, yeah, you know what, maybe modular monoliths in a large number of applications is the right way to get the most cost efficiency out of a deployment of your application, right? So you can see 15x, latency is less by 15x, and you can reduce cost by up to 9x, but again, there's a lot of assumptions there, and if you read the paper, I don't want to spend the whole time talking about this paper, so. All right, so we've covered some basics. We've talked about what cloud pricing looks like. We've talked about different deployment models, right? So what are some things that you can actually do that can help you address cloud cost? Okay, so the biggest problem is over provisioning. Okay, most developers will over provision their application in the cloud if for no other reason that this thing doesn't go off on a Saturday morning when they're trying to do something besides work, right? Because you always want to have a little bit of a safety net. You don't want to provision your things so that it's right at the cusp, right? And I said this before, when you think about what your load looks like, nobody's load ever looks like this. It's always like this, right? So what do you do in that case? You provision for the peak, and then you add 20% for safety in case like something happens, because you don't want your users to have a bad experience. Is that something that's addressable? Maybe. Okay. So resources running, I just put VMs, but having resources running when they're not in use. So someone actually made a really good point. Should you run your CI and CD pipeline every time you do a commit? Is that necessary? How much does that cost? Okay. So third thing is lack of automation. This is simple things like monitoring how much load your services are taking in. You know, have you provisioned enough or provisioned too much in this case, and other kind of automation tools or automation things around it. But getting back to should I run functional tests all the time? That leads to a discussion on lack of governance. So governance is basically having some kind of strategy from the top down. And I know as developers, because I'm a developer myself, I hate having somebody tell me what I can and can't do when it comes to building code. Right? I'm sure everyone in this room agrees with that. Right? Of course, I'm not talking about crazy stuff, but I don't like somebody else to tell me, oh, you can't use this or can't use that, or maybe you should do that. But in certain situations, especially for larger applications, larger teams, larger companies, having a governance model is usually the first step in getting some kind of cost control around all the stuff that you do, right? And that leads into directly one problem is a lack of guardrails, right? Guardrails are essentially something that help protect your application, but also help protect from cost overruns, right? So to give you a very specific example of a guardrail, if you're deploying on cloud functions, whether it's on Amazon Lambda, Azure Cloud Functions, or GCP Cloud Functions, there's a setting in there that you can say, do not create more than this many instances of this cloud function. At some point, you basically just say no, right? Just in case something happens and like you go through the roof, because cloud functions on the small scale are really cheap. Medium scale, reasonably cost efficient, but once you get to the large scale cloud function deployments, it becomes more expensive than just running that stuff on your own VM, okay? And then I mentioned this earlier before, unexpected egress, ingress charges. That's basically data transfers, multi-region, off the cloud, into the cloud, et cetera, right? So those are the key 6 things in terms of what you should be thinking about for cloud costs, okay? Now, let's switch gears a little bit and talk about JVM considerations, because of course this is the Java meetup, right? So, surprisingly, or maybe not surprising to the people in this room, because a lot of people talk shit about Java out on the internet, right? Especially all those people who are in the TypeScript and Python. It's like, oh, I hate Java. It's so crap. I learned it at university, and blah, blah, blah. Java is actually a great tool for power and cost efficiency. And on top of that, it's extremely flexible, right? You can write different kinds of applications, almost every different kind of application using Java. In today's world, you can write cloud functions with Java. Of course, you write monoliths, mobile apps, and everything in between. It's one language for all the models. But that's nice to say, and everyone in this room will agree with that because this is a Java meetup. But let's talk about some of the real things why this can be good, right? One of the great things about the JVM is that it has a JIT, right? The JIT is something that optimizes the code to make it run more efficiently over time, which means you're going to be using less CPU once that code is optimized, right? Standard thing. So we actually use less CPU over time in a Java application. Yeah, the JIT does warm up, and it uses more CPU as it's going through and analyzing and optimizing all that stuff. And so we have that little bit of a ramp up that we have to be aware of, okay? So here's a question for, well, let's look at this first. So unfortunately, I chose the wrong font. Oh, actually, you can see that on that screen. So there's a reference to this specific study on how many joules of power are used by, they basically create a test application, and they ran across all these different, same application across all these different programming platforms. And you can see that Java is actually even more efficient than C#, right? So they have different graphs for VM-based, and this is the interpreted-based languages. So you can see there's, for example, JavaScript is in there, and Perl is incredibly inefficient. Now, who would have thought that, right? Has anyone done like real Perl in the past? Yeah, it's never again. But that's a long story for some other time. Okay, but anyways, you get the idea, right? So if you look at this, Java is extremely efficient in terms of overall energy used to do the same amount of processing, especially compared to the interpreted languages. Okay, so you can see Python is at least, let's see, this is showing Java at about 40 joules, and Python is at about 1,000 joules. So yeah, go ahead, please.
Yeah, just a question. So I did a little bit of hobby myself, measuring energy consumption by different languages. How did they measure DRAM energy? Do you know?
How do they measure what?
The amount of energy the DRAM is actually using in the study, because it's not straightforward, I think.
Yes, you are correct, and I don't remember exactly off the top of my head, but this is not some guys sitting in their basement. This was like a proper study done at a university or something like that. So what I suspect they did is they probably hooked up a multimeter directly onto the RAM bus on a machine. If I remember correctly, I think that's what they actually did, right? They basically just hooked into the junction that powers the RAM and took measurements using a multimeter to do that, right? And then they did overall compute, same thing for compute, and then they also, I believe, measured it directly from the power outlet also.
Yeah.
Okay.
Yeah,
So,
nice.
but anyways, the link is there. You can look it up. Okay. All right. So what are some specific JVM optimizations? All right. But before we get to that, let's talk about some JVM runtime basics first. So I'm going to draw a little diagram here. But before I do that, my question is everyone is familiar with what the JIT is in the JVM, right? It's the thing that goes and optimizes the code to make it run more efficient. So here's a question. Let's make some assumptions first. Let's say you have a moderately sized Spring Boot app, about 1,000 lines of code, which would mean about 500 class files. It's running, modern version of JVM, Spring, et cetera, right? So it has a modern JIT and everything. Now, if you were to put that application under load, how long would it take approximately for the JIT to optimize 95% of the code?
Depends on the load.
Let's say you put it under moderate to heavy load.
Okay.
So you're exercising most of or all of the code paths.
Half an hour.
Okay, that's not a bad guess, actually.
I think it took like 10,000 requests or so, and then things started running more smoothly.
Okay, so 10,000 requests, something like that, modern hardware, doing the math in my head would take about 3 to 5 minutes, right? Approximately, right? So if we say X number of requests per second, et cetera, et cetera. Anybody else want to take a guess?
I was thinking more in the range of seconds, but it's just a guess.
Okay, no, that's fine. Again, this is actually not a trick question. So, because at Azul, we've done measurements on this, comparing OpenJDK with Azul Platform Prime. So, for the scenario that I just gave you, a moderately sized Spring Boot application under heavy load, it will take about 15 minutes for it to reach peak efficiency on OpenJDK hotspot. On Azul Prime, which we have our own JIT compiler, optimizer called Falcon, it would probably take 20 minutes because it's much more aggressive at optimizing the amount of code. I'm sorry, it's much more aggressive at optimizing the code so that you get better performance over time. Okay, so that would take about 20 minutes. That's how long it takes for the JIT to really get warmed up for, again, a moderately sized Spring Boot type of application. Okay, so when we think of how that and other things play into the JVM, I'm sorry. All right, so let's draw a little graph here. Okay, so we'll call this axis CPU, and this is time over here. All right, so when you start your VM, of course, it's going to go straight up. It has to do all the configuration and stuff like that. And then this is what nominally once the JIT kicks in and optimizes code. So let's call this point, this is JIT optimized here. Okay, and this is as the JIT is working to optimize your code between, you know, here and this point right here. Okay, so you have this amount of time approximately where and again, the vertical axis here is CPU. This is how much CPU your application is using when your VM starts up, right? This is not something I've come up with. This has been studied over the years and years. I've seen this before as well when I've done performance optimizations or performance tuning, okay? So if you think of like your standard server environment and then you think of your cloud environment, at this point, up to this point in time, you need to have a fair amount of extra CPU power to be able to have the headroom for the JIT to be able to go and optimize all your code. Okay, so what would you do as a developer in this scenario? Right, you would essentially set the amount of CPU horsepower, the number of cores you need to be at approximately this level. Okay, now there is something on AWS, and the name is called CPU Boost. So you can click a button and say, I want extra CPU when the app is starting up, so things, you know, the whole thing can get started up faster, right? I don't remember if that's configurable, so you can say I want for 5 minutes or 15 minutes or 10 seconds, but I think normally it's just for like the first few seconds as your app is starting up, whether it's a Java app or any other application, right? But the point here is that when we look at this graph, if you set the bar, the amount of CPU cores, et cetera, CPU power you give this application to this level, what's all this right here? Exactly, this is waste. Okay, so this is something to consider, right? So what we want to do is we want to either get rid of this entire section right here somehow, not have this and hit peak optimization right at this point, and then we can set the bar for the amount of horsepower we have at this point. Again, I've obviously made some assumptions here, right? Our load never looks like this. Our load always looks like this, right? Goes up and down. So, but you know, there's this extra headroom here that, yeah, maybe that's good for that kind of stuff, but how do you go and look at this properly to do this, right? So there are a number of ways you can just, when I'm doing performance testing, what I do is I look at just the raw amount of CPU used inside of a Docker container, right? Well, the Docker containers, let's say just VM, right? Hook into something that gives me the CPU utilization graph over time as I start the app up and as it gets optimized for the next 20, 30 minutes and we reach steady state under a heavy load, okay? Now, I'm going to switch. Any questions about this before we move on? Yeah, go ahead.
I'd say that the virtualization, the hypervisor manage this. If A doesn't use it, then over allocation.
Okay, yeah, so you're talking about a hypervisor, right? And yes, there is a hypervisor in the cloud, but you only get a fixed amount of CPU horsepower in the cloud though, right? So if you spin up a VM in the cloud, right, it doesn't like just give you more horsepower, or am I mistaken?
Well, if you allocate, then the things that you do not use does not mean that it isn't used by another VM.
Yes, you're right, but you're still paying for it.
Then I get
Yeah,
the point.
right, yeah. You're still paying for it is my point. Yes, you're not using that CPU power, but you're not paying for it. And here we're trying to think how we can control the cost of this.
Yeah.
You make a very good point. Yes, the cloud provider will reallocate that unused CPU cycles to something else. But it doesn't matter because you're still paying for this VM that has 16 vCores and 16 gigs of RAM or whatever, right? So, okay. So, any other questions before we move on? Well, we're going to talk more about this, but I'm going to switch back to slides now. Yes, please.
AOT, ahead of time
Right. So what you're saying is if you do AOT with something like Quarkus, you can avoid some of this. But you can't avoid the JIT optimization. That only happens at runtime. But yes, you can avoid some of the initial setup stuff that happens with a heavy framework like Spring. I hope the Spring people don't hear that. I just call their framework heavy. So.
Yeah, you can use the optimized image from the Java virtual machine and then deploy that to save some of that.
Yeah.
Yeah.
Yeah. So both are great ideas, and that's exactly what I'm going to talk about next. So okay. Yeah. Oh.
I was just pointing to him.
Oh, okay. Any more questions before we jump back to the slides? All right. All right. So let's go back here. All right. So let me see if we want to jump ahead a little bit. Yeah. Well, let's take a step back here. All right. So another question about this is if you have a short-lived application, say you're running in a Kubernetes environment and you're running pods where you kill a pod every 10 minutes or half an hour or something like that, or whatever, right? Or you just have that kind of load that bounces up and down, or you're running in a cloud function environment where your cloud function will get destroyed every 10 minutes. Does it even make sense to do JIT optimizations for those kinds of environments? No, right? So, I mean, what's the point if you're just going to kill this app in 10 minutes? Now, in all fairness, there's another nuance here. If you build a cloud function, your cloud function should be very small. So that will get optimized very, very quickly, right? Because if you have like 100 lines of code or let's say 500 lines of code in your cloud function, that's going to get exercised on every request going in, and it'll become optimized very, very quickly, like within seconds or minutes at the most, okay? Something else to think about, of course, so that's why I warm up time on here. And then, of course, we have to think about GC pauses and how much CPU GC garbage collection cycle will take, right? So, of course, the hint here is just use less memory so that you don't have these spikes in CPU as you're trying to do garbage collection, and it won't affect the user experience. But, of course, that's not always possible, okay? So, long JIT warm-up means short-lived processes don't benefit from the JIT, okay? So, unfortunately, there's not been enough work done in this area yet to understand, it's like, what do we do with this? Is there a way that we can have a different kind of JIT or just turn it off or whatever, right? So some work needs to be done. And I think that over the next few years, or next few months and years, people will start actually looking at this and saying, actually, maybe we don't need a JIT for this. Okay, now, can it be solved? Yes, it can. So there's something that Azul had put out a few years ago, which is part of OpenJDK now, called CRAC or CRAC. It's basically instant startup for Java applications. It allows you to start a VM with the application, take a snapshot, and then restore from that snapshot later in time. Now, the current thinking about using CRAC, not a lot of people are using this in production yet, but the current thinking is, let's just use Spring Boot as an example, okay? You start up your Spring Boot application, and the current thinking is you take that snapshot of that running JVM at the point at which the Spring Boot app is ready to take its first request. That means all the stuff that Spring Boot does, set up all the beans and the bean factories and all that stuff is set up, database connections are done, Hibernate has gone and done whatever configuration, et cetera, right? That's the point at which you take it. And you get pretty fast startup. So you probably have all seen a presentation on CRAC by now, but in some of the work that we've done in benchmarking this, a Spring Boot application, specifically the Spring PetClink application, which takes about 4 seconds to start up from the time you say go to when it's ready to service the first request. If you're using CRAC, it will start up in 40 milliseconds. So that's 2 orders of magnitude faster, right? So that's a huge difference. That's the main reason people are interested in CRAC. But something that we're working on and other people are also thinking about is, well, instead of doing it at that point in time, taking that snapshot, that save restore snapshot at that point in time, what if we do it after we've exercised the application and warmed the JIT up? Because what CRAC does is it saves everything that's in the VM to disk, and that's what you restore from. So maybe that's one way to do it, okay? Again, not enough work is done. We're so early in this era of using the checkpoint restoring user space, which is at the Linux level. CRAC builds on top of that. We're not quite there yet in terms of understanding what implications that has in terms of your application, okay? So anyways, I don't want to talk too much about this. Is there some JVM configs that we can do? Are there different garbage collection algorithms we want to use in these scenarios? The answer is probably not, but depending on your use case, just having a standard GC might be better. Something that uses less CPU but has more pauses might be a trade-off that you're willing to make and may save you having that extra CPU overhead or having to allocate extra CPU overhead. Okay. Now, let's think about long-running applications. Remember, because this research paper just came out from Google that said, don't do Kubernetes, just build modular monoliths, all right? So let's say we're running, how many people currently maintaining or building monoliths in the room right now? Okay, so about half the audience here, right? How many people are doing microservices? Also, yeah. How many are doing everything, right? It's kitchen sink, right? Let's do everything. Right? So when we think of a long-running application, we have a lot more options in terms of what we can do here. Long-running applications can definitely benefit from tuning the JVM to fit that application's specific needs. We have a number of choices with garbage collectors now. Shenandoah, non-generational Shenandoah just came out with 21. Azul in our high-performance JVM, we have a continuously collecting garbage collector, which is pauseless, called C4. That never pauses. It uses about the same amount of CPU as the other garbage collectors if you aggregate it. And then, of course, we have the JIT, which makes the code more efficient. Azul Prime has its own JIT, which makes your code more efficient over time, right? So we also have a couple of other things which by this point in this presentation, you probably have figured out that, hey, what if we did this or what if we did that, right? So one of the things we have is that we have something called Ready Now that serves an optimized JIT at startup. It basically slurps the disk from a pre-warmed up Java application, stores it, and then injects it into the JVM as it's starting up. And then the next level up from that is something called Cloud Native Compiler. And the scenario for that is actually pretty straightforward. You could probably guess where I'm going with this, right? Just by the name of this thing. You have an application that's deployed. You have 10 nodes of this application. Does it make sense for all 10 of those Java processes to all use the JIT, in each one of them individually, to optimize the JIT? The answer to that is, of course, no. Wouldn't it be great if there was a server just sitting in the background over here that just served up to optimize JIT across all the different instances of those 10 different nodes that you have of the same application? Okay, so both these things are in the commercial product, which is the high-performance VM called Azul Platform Prime. But in all fairness to our peers at other JVM vendors, the folks over at IBM, they make something called OpenJ9, which you've probably heard of. They call theirs something different. I think it's called the Network Compiler Service or something like that, right? So they also have similar technology to us, okay? Just to be fair to them. All right. All right, any questions so far? I'm going to try to wrap up soon so that Paul has enough time to give his presentation. Any questions so far? No? Okay, cool. All right, so let's talk about dealing with non-uniform load, which is one of the bigger questions that we had at the beginning of this, right? Who has load that's always consistent? Nobody, okay? So when I try to think about this, or if I'm working with a customer and trying to think, well, what do we do here? Do we go for the kind of monolith over provision model, or do we go all the way elastic? Of course, the answer here is it all depends. But what I try to keep in mind are the two words I have at the top here, which is what's the SLA that we're trying to aim for, and how much complexity will I add depending on how I move on that app spectrum when I'm architecting an application, okay? Because a monolith is complex, but it's complexity at the code level, right? So how do you build something when you're building a monolith? You say you have a class file, you load up this jar file over here, this library, and you make a direct call to it. It's pretty straightforward. How do you do something that's much more microservice or cloud function based? You have to have this microservice call this other microservice. That adds complexity because you're going over the network now, right? It's not integrated at the code level. It's integrated at the module level, okay? Or at the, well, basically module, but at the service level, okay? So the other problem with going towards that microservice and cloud function kind of environment where you have all these things calling each other is that you're also adding overhead because you're doing data serialization and deserialization, okay? So that's why, unfortunately, I don't have a good answer for you here. Right? It all depends on your application and how much overhead you're willing to give up to get more elastic so you can scale horizontally. All right? Again, the whole point here is the thing that we're trying to keep in the back of our head here is how can we reduce the amount of money we spend on the cloud, i.e. how do we make things more efficient so that we can run less servers and still serve up the same load and still be able to hit those peaks, okay? All right, so I know I said earlier that I don't like Kube. What I do like is containers as a service, because as a developer, I like to focus on building products, building code, building features, and I don't like a lot of complexity. I don't want to deal with that. I basically want to say, here's a Docker container with my Java app. Go scale and do all the bullshit for me so I don't need to, right? That's why I like CaaS solutions. And of course, on Amazon, it's called Fargate. On Azure, it's called Azure Containers. Is that right? Does anyone know? And on GCP, it's called Google Cloud Run, okay? So again, here's a container, scale it for me and handle all the bullshit so I don't need to. Right, and so Cloud Functions is always an interesting topic around cost, right? It gives you the ultimate in elasticity. Scale down to 0 when nothing is hitting it, okay? But again, like microservices, you have all these Cloud Functions which are calling each other. It introduces complexity at the modular level, which maybe I'm just been doing coding for too long. I prefer to have my integration between different things, like you're hitting a security service, or you're calling a database. I like all that integration to happen at the code level because I can just open up my IDE and click, click, click and see everything that's happening very quickly. Whereas if you do it here at a higher level with these microservices or cloud functions calling each other, it's much more difficult to reason and understand about that specific application as a whole. And also what happens if you just want to change this one cloud function, but you have these 20 other cloud functions or microservices depending on it. Right? How do you then navigate the change process around that? Right? That has nothing to do with cloud cost, but it's just something to think about. Okay? So again, it's re-architecting. It requires a new way of re-architecting an application. It's not easy, and we haven't built the tools. In my opinion, we haven't built the tools yet to help us as an individual developer and as a team reason and think about this and how do we apply changes and how do we do rolling deployments and things like that. Okay, now, I did mention Graviton earlier, so I want to drop some stats in here at the end. Graviton only came out a few years ago. Graviton, again, is ARM-based processors for compute. And as you guys know, the JVM also runs on ARM-based processors, and there's, we have a VM, all our VMs, Zulu and Core, both run on Graviton. We also are going to have it for our high-performance product, Prime. But Graviton is typically 50% or more less expensive than x86 for compute. Okay. Now, how many people in this room are using Graviton for production deployments? Okay.
Hobby project, but
hobby project, yeah.
Yeah, but yeah, especially the smallest ones, they're super cheap. Like so you have like half a gig and 2 CPU for like $5 a month.
Yeah, that's pretty cheap, right?
Yeah.
How many vCPUs?
2.
2. Okay, that's actually really cheap, right?
Yeah.
So here's a question for everybody. Why have you not considered moving to ARM? I mean, it's been out for like 4 years now, 3-4 years.
Is there any compatibility downsides or something? I know the M1, the M series.
Yeah. Okay. So it's a really good question. The question was, are there any compatibility issues for a JVM running on Graviton versus a JVM running on x86?
Including its landscapes and dependencies. Yeah.
Absolutely. That's the huge concern. Now, and I don't know the answer to that for your application or for, just in general, but if you're not doing JNI, right, calling out to your own native libraries, is it really a concern? And the other question is how hard is it to try this? It's not, right? You just say, here's a container, let's slap it up onto an an ARM versus x86 deployment platform. I don't know. Anyways, I'm not giving you a hard time. It's just, see, as developers, we get a little bit too entrenched, and we don't want this thing to go off on Sunday morning at 4 a.m. while we're trying to sleep, right? So we we're very adventurous when it comes to how we code or what libraries we use, or maybe we're insane and we use something like Scala to write applications, but I'm just kidding. But you get the idea. We're very adventurous on this side, but when it comes to actually deploying stuff and managing it in production, we tend to be extremely conservative. Is that true or not true? Right. I think everyone in this room as a developer will agree with that. So, anyways, yes.
Yeah, so one of the things I wanted to add to this, like, so for those that know Bitnami, I'm not sure that rings a bell to anyone here, but basically support everything that's Bitnami supports are all production grade supported, enterprise grade supported for ARM as well. So,
right.
And that contains, I think, practically everything in the Java ecosystem as well, like from Kafka, Postgres, everyone. All of those are enterprise ready for ARM. So
yep. Yeah. So
there should not be any issue with compatibility issues anymore. Also not with M1 laptops, M2 laptops. So
yep.
Maybe the first couple of months, but after that, like, so
yep.
there's if you want to be more sure about like how that works out, like also with cloud, there's a bunch of white papers or articles from Honeycomb.io. They've done a lot of like in-depth analysis on how they moved to Graviton and how that worked out for them. So
yep, that's right. The Honeycomb.io article has a lot of good stuff in terms of migrating off of x86, and their stuff is mostly based on Java, JVM, right?
Yeah, so, well, they have different tooling. I'm not sure
of course,
exactly
yeah.
all of the languages for all this stuff, but I think they explain exactly, and they
okay.
show how they did that, how they measure it, where the benefits are, where it wasn't, but in general, like, the statements what you say here definitely ring true to what they say as well.
Okay,
so
thanks.
I see no reason to not do it. So, for example, I now make sure that everything I compile or anything I build or every container is all multi-architecture.
Right.
Then you can run it anywhere you want.
Yep, absolutely. So anyways, short answer is there's very high probability that your Java app will just work on Graviton and ARM without having to change anything. Okay. All right. The final thing I want to close on, and we were having a discussion about this earlier. If you're using managed services, where's the line between paying extra for that managed service versus doing it yourself? Now, DevOps and developers are not cheap. They are very expensive. But if you have a massive Kafka or Cassandra deployment, right, where's that point on that graph where it's actually cheaper for you to have your own team manage it versus paying extra to use managed Kafka or managed Cassandra or manage whatever, right, in the cloud, as opposed to doing it yourself. So when I think about this from an architect or from talking with the customer and they're looking at different things, I tell them that it's great to start off a project with a managed service, but you have to have a plan up front for moving off of that at some point. So, oh, someone's here. All right. So finally, I'll say good luck, because a lot of this has been, the answer has been, it depends. But hopefully I gave you some insights into how I think about this and gave you some statistics, those 6 key points in terms of what to think about to manage cloud costs as a developer. Okay. And again, I'll send the slides out. Does everyone know what Fuje is, by the way? Have you heard of this? Okay, so Fuje is a community website that's supported by Azul and we have lots of great content. How many new articles out there do we put every month? Or do authors put out every month?
It's 10 per week.
Yeah, 10 per week. So about, so lots of articles. And the reason why I have this up here is that if you're interested in writing an article, it's completely free. Again, it's a 100% community open platform. And you can talk to Dirchan about setting up an account, and he'll help you get started with your first article on Fuje and everything. Okay. And with that, I will end, and thank you for your time. I'll get off stage so Paul can set up. Thank you, everyone.